When you look up at the night sky, you're peering into a cosmic ocean filled with stars, galaxies, and mysteries beyond imagination. Among the most captivating are black holes, regions where space and time break down. They're not magical portals or monsters, but real phenomena governed by physics. I'm Abdul Hannan, and you're watching Info Family. Today we'll unravel what black holes are, how they form, and why they fascinate us. Buckle up for a journey into the universe's most extreme mysteries. To truly grasp how black holes form, let's journey back to the year 1916. This was when the German physicist Karl Schwarzschild, working with Einstein's groundbreaking theory of general relativity, made a remarkable prediction. He realized that if you could compress a large enough amount of mass into a tiny, compact region of space, the resulting gravity would become so intense that nothing, not even light itself, could escape its pull. This was a radical idea at the time, suggesting that the universe could contain invisible objects with gravity so strong they would warp the very fabric of space and time around them. Schwarzschild's equations described a point where the known laws of physics would break down, a place we now call a singularity, hidden behind a mysterious boundary known as the event horizon. For decades, black holes remained a mathematical curiosity, until 1971, when astronomers made a stunning discovery. They found Cygnus X1, a powerful X-ray source in our own Milky Way galaxy. This was the first strong evidence of a real black hole. Cygnus X1 is part of a binary system, where a collapsed star is pulling matter from its companion. As this matter spirals in, it heats up and emits X-rays, revealing the presence of an invisible, all-consuming object. This discovery transformed black holes from theoretical oddities into real, observable phenomena. But how does a black hole actually form? The process begins with a massive star, many times heavier than our sun. When it exhausts its nuclear fuel, it can no longer support itself against gravity. The core collapses under its own immense weight, compressing matter into an infinitely dense point, a singularity. Around this singularity forms the event horizon, the ultimate point of no return. Anything that crosses this boundary, even light, is lost forever to the black hole's gravity. The outer layers of the star may explode outward in a brilliant supernova, but the core remains, transformed into one of the universe's most mysterious objects. To put this in perspective, imagine taking the entire mass of our sun and squeezing it down into a sphere no bigger than a city. The resulting black hole would be incredibly dense, with gravity so strong that nothing nearby could escape its grasp. This mind-bending transformation is what makes black holes so fascinating and so extreme. The first black hole we ever detected, Cygnus X1, lies over 6,000 light-years away from Earth. That means the light we see from it today began its journey long before humans even walked the planet. Its story is ancient, stretching back to a time before our species existed, reminding us how black holes are both relics of the distant past and active players in the universe today. Black holes aren't just theoretical constructs, they are the dramatic result of nature's most powerful forces at work. Their gravity can twist and bend space, slow down time, and even tear apart entire stars. Observing them helps us test the limits of physics and understand the universe's most extreme environments. And black holes come in more varieties than you might expect. From stellar mass black holes formed by dying stars, to supermassive giants lurking at the centers of galaxies, to mysterious intermediate and even primordial black holes that may have formed in the early universe, each type tells a different story about cosmic evolution. So, what are the different types of black holes, and how do they shape the cosmos? Let's dive deeper and explore the fascinating diversity of these cosmic enigmas. Transition to next scene. Black holes come in several fascinating types, each representing a different chapter in the universe's story. These cosmic enigmas are not all the same. Each type has its own unique characteristics, origins, and mysteries that continue to intrigue astronomers and physicists alike. The diversity of black holes reflects the incredible variety of processes that shape our cosmos. From the earliest moments after the Big Bang to the centers of modern galaxies, black holes are found everywhere, each with a unique origin and role in the universe. Primordial black holes, for example, are thought to have formed just fractions of a second after the Big Bang. These black holes could be as small as an atom, but possess the mass of a mountain, making them incredibly dense. Scientists believe they might even help explain some of the universe's mysterious dark matter. The most common type, stellar black holes, are born from the dramatic deaths of massive stars. When these stars run out of fuel, they explode in a supernova, and their cores collapse under gravity's pull, forming a black hole. These are scattered throughout galaxies, including our own Milky Way. Intermediate black holes are a mysterious middle ground. They are hundreds to thousands of times more massive than our Sun, and are believed to form when stars merge in dense star clusters. Although harder to detect, recent discoveries suggest they may be more common than once thought. At the heart of nearly every large galaxy lies a supermassive black hole. These giants, with masses millions or even billions of times that of the Sun, anchor galaxies like our Milky Way and power some of the brightest objects in the universe, quasars. The origins of supermassive black holes remain one of astronomy's greatest mysteries. Did they form from the merging of smaller black holes, or did they grow rapidly in the early universe? What we do know is that they play a crucial role in shaping galaxies and regulating their growth over billions of years. From the tiniest primordial black holes to the colossal supermassive ones, black holes exist on every scale, connecting the smallest and largest structures in the cosmos. They are key to understanding how the universe has evolved. Each type of black hole reveals a different chapter in cosmic history, offering clues about the universe's past, present, and future. By studying them, we unlock secrets about the very fabric of space and time. Imagine for a moment what it would be like to fall into a black hole. This isn't just science fiction. Black holes are real, mysterious objects scattered throughout our universe, and their pull is so powerful that not even light can escape. But what would actually happen if you, or anything else, crossed the point of no return? As you drift closer to the event horizon, the invisible boundary surrounding a black hole, gravity becomes unimaginably intense. The difference in gravitational pull between your feet and your head would be so extreme that you'd be stretched out, a process scientists call spaghettification. Your body would elongate, pulled apart atom by atom, as the black hole's gravity overwhelms every force holding you together. But that's not all. Time itself behaves strangely near a black hole. To someone watching from a safe distance, you'd appear to slow down, moving in slow motion as you approach the event horizon. In fact, from their perspective, you'd seem to freeze in place, never quite crossing the boundary. But for you, time would feel normal, until the moment gravity tears you apart. Black holes don't just consume people, they devour entire stars. Astronomers have observed these cosmic monsters ripping apart massive suns, creating spectacular bursts of energy that can be seen across the universe. These events, called tidal disruption events, are some of the most violent and energetic phenomena we know of. No human has ever fallen into a black hole, and it's unlikely anyone ever will. But by watching these cosmic feeding frenzies, scientists can study the incredible power and destructive force of black holes, learning more about the fundamental laws that govern our universe. The idea of falling in is terrifying, but it also offers a glimpse into the wildest extremes of physics, where gravity, space, and time all behave in ways that defy our everyday experience. At the edge of a black hole, the rules of space and time are pushed to their absolute limits, challenging everything we think we know about the universe. Transition to next scene. Next. If black holes are invisible, how do we see them? The answer: by their effects on nearby matter. Matter falling in forms a superheated accretion disk, emitting X-rays and high-energy light. In 2019, the Event Horizon Telescope captured the first image of a black hole's shadow surrounded by a glowing ring. We also detect black holes by observing stars orbiting invisible objects or jets of particles they launch. Their gravitational influence and the chaos they create give them away. It's cosmic detective work, solving mysteries with clues scattered across the universe. We see their mark, not the black hole itself. What if our sun became a black hole? Don't worry, it's too small for that fate, but if it did, its mass would stay the same, just compressed into a tiny space. The planets, including Earth, would keep orbiting as before. Gravity depends on mass and distance. However, without sunlight, life on Earth would end quickly as temperatures plummet and the planet freezes. Our solar system would become a dark, icy wasteland orbiting an invisible void. Black holes aren't galaxy-eating monsters. Physics keeps everything in balance. The sun's warmth is what makes life possible. Could a black hole swallow our galaxy? No, Even the largest supermassive black holes are tiny compared to a galaxy's vastness. The Milky Way's central black hole, Sagittarius A*, is massive but only a fraction of the galaxy's mass. Black holes need material to fall in. Most stars and gas orbit safely, never getting close. Think of a black hole as a drain in a giant pool. Only nearby water gets pulled in. Galaxies and their black holes have coexisted for billions of years. If black holes could consume galaxies, the universe would be much emptier. The universe plays by careful rules, even with its darkest mysteries. Imagine Earth drifting too close to a massive black hole. Gravity would increase, pulling us faster toward the center. From afar, we'd appear frozen at the event horizon, but on Earth, tidal forces would stretch and tear the planet apart. The result? Earth becomes a stream of atoms spiraling into the abyss. Science tells us there's no return or survival. Information is lost, at least as far as we know. The fate of matter inside a black hole remains a great mystery. Are things lost forever, or could they escape? That's a question that keeps scientists searching. The physics is sobering: obliteration, not transcendence. Once you cross a black hole's event horizon, escape is impossible. The required speed exceeds that of light. Hollywood imagines daring escapes, but physics says every path leads deeper toward the singularity. Some theories suggest wormholes or quantum effects, but there's no evidence yet. For now, the best advice: stay far away from black holes. Their boundaries are absolute. Cross them, and you're lost to the universe. How do we study black holes so far away? Advanced telescopes capture X-rays, radio waves, and infrared light from their surroundings. The James Webb Space Telescope and the Event Horizon Telescope let us see black holes in distant galaxies and even image their shadows. Scientists also detect gravitational waves from colliding black holes using instruments like LIGO and Virgo. These tools let us study black holes across the universe, looking back in time. Our curiosity and technology shine light into the universe's darkest corners. Black holes are extreme, but could there be something even stranger? Some physicists propose white holes, theoretical opposites that expel matter and energy. White holes remain hypothetical, we haven't seen any, and their existence would challenge our understanding of space and time. The universe is full of surprises, and every discovery opens new questions. Science thrives on the unknown. Our greatest discoveries may still lie ahead. Stay tuned for more cosmic mysteries in future videos. Thanks for joining me on this journey through the universe's darkest mysteries. I hope you discovered something new and awe-inspiring. If you enjoyed this, like and subscribe to Info Family for more deep dives into the cosmos. Until next time, keep looking up and stay curious. Let me know if you need further tightening or adjustments.